Hello, this is Isaac, Eric, and Michael. We will be presenting our project for ECEN 361 Embedded Systems. This project is an autonomous snowplow which basically will be a robot that can sense and stay within certain boundaries. This robot is based on an idea similar to the Roomba vacuums that will run on a schedule to perform a menial task that we humans, for the most part, hate doing. Similar to the Roomba, the robot will stay within present boundaries with the addition of staying on a programmed course rather than bouncing around the room. The robot is obviously much bigger and will require much more torque than the Roomba because it will need to push snow, and will also be required to be rugged enough to survive the harsh winters we face here in Idaho.
In order to build the robot, we outsourced the mechanical portion of this project to the Idaho Falls robotics team, Team 1566, the Ammo Knights. They built us a chassis that included motors and gearboxes, capable of producing the torque needed to push snow. What we did from that point was add several electrical components such as Victor 884s, which are a type of motor controller, a power distribution board, a 12-volt battery with a kill switch attached, and to run everything we used an Arduino Mega. To establish our perimeter, we used 4 light sensors on the front that would read low when they passed over shiny duct tape. When the perimeter was crossed, the robot will back up for a period of 1.5 seconds, turn either right or left depending on which pass it's on, and continue going the opposite direction.
Some future improvements to the project that we would like to add would be integrating a weather app to feed information to the robot so that it knows when it needs to go out and plow snow. Another improvement we'd like to see is to create an inductive charging pad and home dock for the plow to return to after its job to recharge and prepare for its next task. We'll also be replacing the duct tape light sensor with an inductive fence to create a more reliable perimeter that will not be inhibited by being covered with snow. At the conference, a great suggestion given to us by one of the judges was to add a hopper that would distribute salt behind the robot to cover the area it has already plowed. At the home dock mentioned earlier, it would then be refilled with salt and prepare for the next plowing job. Because our biggest issue during testing was traction, we would want to replace our wheels with either treads or to screw studs into solid rubber wheels instead of air-filled ones to increase traction and ultimately increase torque.